Hey everybody, welcome to another Con support video. This one is on interpreting scale factor in scale drawings. So let's get to work on this one. It says, interpret the scale factor in scale drawings. Ivan made a scale copy of the following triangle. He used a scale factor of less than 1. So anytime you use a scale factor just in general of less than 1, it means that you're going to be reducing the size, right? So if you think about it, right, so 0% is nothing, okay? 100% is the whole thing, okay? So this is 0, nothing. 100% is the whole thing. And then if you were to like expand beyond 100%, you're talking about something that is greater than the whole, right? So 100% plus is going to be greater than the whole, right? So anything in this range of 0 to, well, up to 100%, not including it, right? So from 0 up to 100%, but not including it, right, would be a reduction, right? So you're reducing the size as a scale factor, right? So it's 50%, 60%, whatever it might be. When you get to 100%, that means that you are multiplying by 1, it's going to stay the same. So that's the same size. And then anything that is beyond 100%, right? Anything that goes to that 100% plus region as a multiplier, right, is where you're enlarging. So let's just take a look at that concept as we go through these problems. All right, so 0% to 100% up to that is a reduction. So then anything that is 100% is multiplied by 1, stays the same. Anything that's larger than 100% as a multiplier as a scale factor is going to be an enlargement. All right, so let's take a look. In terms of scale factor, we're talking about between 0 and 1. Anything that is between 0 and 1, but not including 1, is going to be a reduction. And then anything that is from 1 beyond 1, not including 1, is going to be an enlargement. And this could be any number, right? This could be positive infinity over here. All right, cool. So let's get to work on this one. It says, Ivan made a scale copy of the following triangle. He used a scale factor of less than 1. What could be the length of the base of the scale copy of the triangle? Well, it has to be a value that is less than 1, right? What could be the length of the base of the scale copy of the triangle? Well, it could be anything less than 1. So anything that, it could be any size as long as it's less than 5, right? So 100% in this case would be 5, right? Okay, so that would mean it stays the same size. It's not going to be 5 because it's less than 1 as a scale factor. So it has to be something that's less than 5. So anything that is less than 5 will work. So 4.5 will work, 2 will work, and a half will work. Any of those could work. 6 isn't going to work because it's bigger than 5. It's an enlargement. And 10 is not going to work because it's an enlargement. It's bigger than 5. So when your scale factor is less than 1, you're going to reduce. So it's got to be less than the value you see, less than 5. Let's look at the next one. It says, Kusai made a scale copy of the following trapezoid. He used a scale factor of less than 1. Once again, you're looking at a value that is less than 1. So we just got to figure out what value they're talking about on this one, and then it's going to be less than that value. So I'm going to copy this image so I can like write on it. I'll paste it over here so we can take a look at it. Okay, cool. It's better. So taking a look at this one, says what could be the length of the longer base of the scaled copy of the trapezoid, the longer base. So when you have a trapezoid, the two parallel sides are the bases. That's what that means. So trapezoids have two parallel sides, right? One set of parallel sides, and then two intersecting sides. The two parallel sides are the bases. The longer base is just the one that's longer, right? So what they're really talking about is this length from A to B. That's the length they're talking about here. That's 1, 2, 3, 4, 5, 6 units. So that length is 6 units, all right? So we're looking for values that are less than 6 because it's a reduction, right? Somewhere in the reducing category. And it's reducing that 6 to something smaller than 6. So what values are less than 6? Well, not 8.7, not 12. So it must be these three. And we can see that that's definitely less. This is the same as 2 and 1/3, which is less. And this is 4, which is less. So that's how you do it. Okay, this one says greater than 1. Great. So this is an enlargement, all right? So it says, what could be the side length of any scale copy of the square that is greater than 1 scale factor? So this means we're going to make something that's bigger than 20, right? So I don't think we need to spend a lot of time on this problem. It's super easy. So we just want values that are greater than 20. So, all right, that and that. those are values that are greater than 20. Is 20 going to work? No, because 20 will be a scale factor of 1, right? Whenever you keep it the same length, that means you're times it by a scale factor of 1. It's 100% of the original. It's the same as the original. If greater than 1, that means it's more than 100%. It's going to enlarge. So this is going to be the two answers that work, 27 and 50. This one says also greater than 1. So this is another one where we're going to enlarge, okay? So you're going to enlarge. So it says, what could be the side length of the scaled copy of the rhombus? Well, what is the side length of this rhombus? 1, 2, 3, 4, 5. So 5. So basically what that's telling you is that it's got to be greater than 5. So I think this is pretty easy. It's going to be 7.3 and 8. That's how you do it. It's just, if the scale factor is greater than 1, it's an enlargement, right? And if the scale factor is between 0 and 1, or less than 1 in this case, it is a reduction, right? So if it's a 1, it stays the same. More than 1 is a multiplier, then it's going to get bigger. Less than 1 is a multiplier, between 0 and 1, really, because we're not talking about negative values, would be a reduction. So they get smaller. I hope that helped, guys.